Find the standard deviation for the following two data sets. All right, so we have data set A or sample A. It consists of these 7 numbers. We got 8, 10, 12, 14, 16, 18, and 20. And sample B also has 7 numbers, but they are 8, 8, 8, 14, 20, 20, and 20. All right, so if you want to find the standard deviation, there's 7 steps. So hopefully you have the notes or you've looked up how to find the standard deviation. Okay, the first thing we want to do is we want to find the mean. Okay, so we got to add all these 7 numbers together and then divide that by 7. Okay, so the mean in this case for sample A is going to be 14. Okay, and same thing with sample B. We'll add all these 7 numbers together, add them up, and then divide by 7. And we actually get the same mean, right? The mean in this case is going to be 14. All right, so for sample A, okay, in order to find the standard deviation, we're going to do these steps, right? The deviation is how far away each data item is from the mean. So 8 minus 14 gives us negative 6. 10 minus 14 gives us negative 4. Okay, 12 minus 14 is negative 2. 14 minus 14 is 0. And then 16 minus 14 is 2. 18 minus 14 is 4. And 20 minus 14 is 6. Okay, so that's called a deviation, right? So this is going to be each data item minus the mean. So in this case, each data item minus 14. Now you notice that these values are negative. Okay? But for the next step, we have to square the deviation. Okay? So negative 6 squared is equal to a positive 36. So you got to make sure that all the values in this column here are all positive. Okay, negative 4 squared is 16. Negative 2 squared is 4. 0 squared is just 0, of course. And we get 2 squared, 4 squared, which is 16, and 6 squared, which is 36. So when we add all these 7 values together, right, the sum in this case is 112. All right, so we got a couple steps left here, right? We want to divide this by n minus 1. Okay, now in this case, there are 7 data values. Okay, so we want to divide this by 6. Okay, and this gives us, 18.6666 repeating. Okay, and then once we take the square root of that, this will be the last step here. Remember, don't round this. You just want to make sure you keep these values and then just take the square root of this guy. Okay, and then round this to now in your calculators, right? We should get something like this, and we'll round it to 2 decimal values, so we get 4.32. That is the standard deviation of this data set. Okay, it tells us the spread of the data. Okay, now in and itself, right, it doesn't really mean, it tells us a couple things, right? But the idea is, right, let's take a look at sample B. Let's find the standard deviation of sample B and see how that compares. Okay, so just by looking at this, would you think the standard deviation of sample B is bigger than 4.32 or less than 4.32? Okay, and we can sort of figure out the answer just by looking at how the values, right, how these values are spread compared to these values. Remember, the mean is the same. The mean is 14. So let's go ahead, right? 8 minus 14, right? We're finding a deviation. So we're going to subtract 14 from each of these numbers. 8 minus 14 is negative 6. You get another negative 6 and a negative 6. 14 minus 14 is 0. Then 20 minus 14 is 6. So these are all going to be 6 here. Notice that when we square this, negative 6 squared is 36. So these all actually just becomes 36s here, right? And when we add these 7 numbers together, okay, we get 216. Okay, and then once again, we have to divide that by n minus 1. There are 7 data values, so we're going to divide this by 7 minus 1. We're going to divide this by 6 to get 36. And then lastly, the square root of 36, which is 6. This is a standard deviation of sample B. Think about what this number actually is telling us here, right? If you notice, well, the mean is 14, right? We calculated that. But don't you notice here that every data value is 6 units away from the mean here? And that's exactly what the standard deviation is saying. That's the spread of the data. Okay, and what about for sample A? Okay, well, some are 6 units away, some are 4 units away, some are 2 units away, right? So hopefully just by looking at the data, yes, we could have determined that the standard deviation of sample B would be greater than the standard deviation of sample A, even though they have the same number of data values, even though they have the same mean.